In this moment, as you study the immune system, it's working tirelessly to fend off the pathogens that would do your body harm. In this lesson, we'll be defining active and passive immunity and describing how they can both be acquired naturally and artificially. When you encounter a pathogen or foreign substance, your body produces memory cells, white blood cells that will produce a rapid response the next time that pathogen is detected. Any encounter that produces these memory cells results in active immunity. Active immunity can be natural or artificial. If you're directly exposed to an antigen, say you get the flu, the process by which your body produces memory cells is natural active immunity. On the other hand, clinical exposure to a pathogen through a vaccine results in artificially acquired active immunity. The vaccine exposes a patient to weakened or dead pathogens. This gives them an opportunity to produce memory cells without the risks that go along with a natural encounter with that pathogen. While active immunity allows an individual to generate their own defense to a pathogen, passive immunity involves passing the tools for defense from one individual to another. Unlike active immunity, passive immunity doesn't involve the production of memory cells. Instead, it involves the transfer of antibodies that can neutralize various pathogens. Naturally acquired passive immunity occurs when a birth parent transfers antibodies to a fetus or infant who is still developing their own immune system. Before birth, this is done through the placenta. After birth, antibodies are passed through a parent's milk. When specific antibodies are administered to a patient by a doctor and not from a parent to a child, the passive immunity this produces is said to be artificially acquired. When someone is bitten by a rabid animal, for example, doctors may deliver rabies antibodies to the patient, in addition to a vaccine. These antibodies are capable of neutralizing the rabies virus, even if they won't stimulate the production of memory cells. The interplay between both forms of natural and artificial immunity demonstrate how immunity is communal. Whether a parent is transferring antibodies to their child, or a doctor is providing a patient with a vaccine, we rely on one another's individual immune systems to bolster our collective defenses.